day, everyone. Welcome to IoT Design Week 2019. My name is Matt Dickens, and I'm here with my partners, Abhi and Xavier. Before we get started, I just wanted to announce the winners of the Pick24F Curiosity Boards. This is Wednesday of IoT Design Week, and we're handing out different prizes each day. So if we can grab those winners up real fast, get that slide going. We have Mohan Kumar, Luis De La Cruz, Matej Nojic, Nina Storbach, and Christian Carrera. So congratulations all. Feel free to email us at livestream@microchip.com, and we can go ahead and make sure we get your number and your address. We need that for shipping purposes. So congratulations to you all. If you don't end up winning today, make sure that you check back the other days, and we'll have some other great prizes coming up the rest of this week, and we'll touch on that a little bit more later. But like I said, welcome to IoT Design Week. Today we are going to be talking about security. So how to secure the Internet of Things, getting started. Before we get started, let's take it back to the booth, and Wayne and Rachel can tell you a little bit about how to ask questions and things like that.
Hey everybody.
Hi everyone. We are also adding on a giveaway. We'll be giving out 3 Pick IoT WG boards. So that's our new smart connected secure board. So to participate in that, just comment in the chat and we will draw winners at the end. And throughout the live stream, feel free to comment and ask questions in the chat, and we will notify the hosts so that they can answer them.
And by the way, everybody give a warm welcome to Rachel and her first time in the booth.
Oh yeah.
You may have seen her for the last 2 or 3 days. I can't remember because the week's kind of running all together at this point. But you may have seen her on the stage. It's first time in the booth. We have like 10 computers here running, and it's kind of it's a lot of really cool and fun things we're doing back here to make sure this thing goes off smoothly. So welcome. It's great to have you.
Thank you.
Comment, please. Make sure you give us a little bit of your thoughts, your questions. We'll get them out to the guys on stage. And I think is that all? Are we good?
Yeah, I think so. Just if you're here for IoT Design Week, just remember it's a whole week. So tomorrow we will have DigiKey in town, and we'll have a brief live stream. So it'll be a little shorter than this one. They'll be showing off some of their tools. So yeah, just keep checking in every day. All right, back to you, Matt.
Awesome. Thanks, Rachel. So before we jump into things, obviously I have 2, Xavier's not new to the live stream, but Abhi is. So can you tell the audience out there a little bit about what you do at Microchip?
All right. Hello, my name is Abhi, and again, I'm from Secure Products Group, and I'm Applications Manager. And my job really is to make the product secure and to make this guy happy, Xavier, because he is the marketing guy who gives a lot of tough requirements that we need to keep him happy about.
And my name is Xavier Bignale. I'm the product marketing manager for the Secure Product Group. And my job is to toss a lot of challenges at Abhi, which they have been addressing very nicely so far.
And my job is to try to bring them to you guys and make sure that everything goes off smoothly. So with that, let's get started. So like I said, today we're talking about security. And I think the big question around security, or really the first question to answer, is why do I even care about security, especially when I'm talking about IoT and things like that? What do I need to worry about when it comes to security?
So why do you need security today? I mean, there are a couple of, if you take the high-level reasons why, right? It's not, you don't need security because you have a PCB, right? There are actually specific reasons. Some of the hacks that we see today are made because of pride, because of unethical hacking, for example.
Okay.
Someone wants to step up and show up and say, hey, I've done it. Achievement.
Yeah.
Research and development. Now you have the R&D market with researchers that are trying to discover new point of attack to mature the technology to the next level and make sure it's not happening again. If you push the thought process to, not really to the extreme, it's real, you see it in the news, espionage, right? Once and for all.
Oh, yeah.
What's behind all of that? There is a financial interest into getting access to something. There is a value, financial value, to access to a credential, an IP, and so forth. And that's what you want to protect, and that's why you need security today.
Gotcha. And I know that with engineering and even with IoT, there can be a lot of different industries and things like that. So are there specific industries that security really applies to, or is it a one-size-fits-all kind of a solution?
Well, that's a recurring question we have is where can we use your technology? Who is using your technology? Pretty much all over the spectrum.
Okay.
As soon as you have something connected, you will need security in some shape or form. So if we decompose the marketplace that we play into, industrial, consumer, medical, automotive, and I'm probably forgetting other markets, but those are the big ones really. If you think about industrial, you see big factories. What is the value behind the big factory? You've got $1 million machines that are set up into an internal network that are now going to be exposed to a public network at some point in the process, right? On the medical side, the biggest memory I had was with one of our partner, Design House. So the CEO of that company, his son has a pretty bad disease, and what the doctors have given to him is a Bluetooth-enabled device that controls the medicine he's taking, and he's controlling his heart and stuff. Well, it controls the heartbeat, right? Now, if you attack the Bluetooth, you control the heartbeat of the person.
Oh, wow.
We're talking about death now.
Right.
So that's why security. Another example could be the automotive. We announced last year a security solution to protect the CAN FD and the Ethernet networks in cars. What's the value behind that? That's the car. Who is inside the car? People. Who's behind the people? Legislations, governments, right, all across the world.
Right.
Now you want to ask why security? This is why.
Gotcha. So it's protecting, there's really a financial gain, but there's even a human gain as well. I mean, so many of the things that we don't even register are connected to the internet are starting to become connected, and we see them as convenience, but as designers, our responsibility is really to protect that convenience and make it safe for everyone, it sounds like.
Exactly. And don't forget the legal aspect of the same.
And the legal, absolutely. Great. So kind of moving forward then, when we say security, what does that mean, especially when it comes to IoT?
So to tackle the word security, you've got to decompose it with three basic fundamental pillars. What you'll hear us talking a lot about in the embedded industry are the concept of confidentiality, integrity, and authenticity, right? All of them are necessary to build a secure ecosystem. So what does it mean if we take it to the embedded side? That means you have each device have to have a unique, trusted identity that's protected. You need to rely and trust the code you're running on at boot. We talk about secure boot. And then that firmware that runs your system, your IP, you also have to update it sometimes. So you have to have a secure upgrade system of your firmware. To upgrade that, you need a secure communication to talk between your edge node and the cloud backend, for example. And then on the cloud side of things, each of the cloud providers are providing services that are monitoring what's trying to connect to it, right? The authentication side of it. They will verify the integrity of the messages that comes from the edge node. That's integrity there. And the confidentiality is all about encryptions, both during the communication and at rest on the cloud. And they have a whole bunch of stuff. We had a rule a few live streams ago that talks about that, and I think they're going to probably come back in a few weeks.
Great, great. So we've got confidentiality, we've got integrity, and we've got authenticity, and these are kind of the pillars that all IoT security are based on.
Yes.
Gotcha. Okay, and so I've heard as well that embedded security can kind of be likened almost to like a key in a lock. And so can you maybe speak to that analogy a little bit more, or tell us a little bit about what it seems like it wouldn't be quite that simple, but maybe it is, I don't know.
Yeah, I mean, the whole concept of security can be boiled down to these two things, right? The lock and the key, for easy to understand perspective.
Yeah.
Maybe I'll try to bring an analogy.
Okay.
You have a lock that you go to a store, you buy a lock, and you buy a lock, I buy the same brand lock. The only thing that is different between you and me is the key.
Right.
Now, obviously, you want to buy a good lock, which is pretty strong, which means you can put that into perspective that that's the algorithms, the protocols. Mm-hmm. And what is different between your product and my product is the key. So both have to be strong, both have to be relevant. Security is as strong as the weakest link.
Right.
So if you have a fancy lock, a great lock, but you take your key, you lock your door, and you put the key under your mat, front door mat. yes, it's great. It's nobody can get into it.
Right.
But if somebody kind of looks into the mat, they can get the key.
Sure.
They don't have to break the lock. They just have to open the key, open the door. So the same analogy, you can pretty much bring it into the IoT segment. In the IoT products, again, every device, every product has to ensure that it is doing both in a professional way and in a robust way, which is you have to have the right algorithms, which
Okay.
is the standards-driven algorithms, and you need to make sure that the keys are properly maintained and stored
Okay.
in those devices.
Okay.
So from an algorithm perspective, I can, sometimes we talk to some customers where they say that, I'm using this fancy algorithm, fancy protocol that nobody really knows about. That's a problem because nobody has tested the validity and the robustness of that
Right.
algorithm. So, I mean, there are even examples over the past where, some companies have, came up with some new algorithms that are not well published, and they said that, this algorithm is good because nobody really knows about this. So it's only that I know how to use this algorithm, so it is security by obscurity.
Sure.
Nobody really knows about it. And the whole concept, I think if there is a slide which talks about it also, which is about the standards-driven algorithms, where everybody should really be using the well-published algorithms, and the only thing that should be different between different ecosystems or different devices is to be the key. And the key point that you need to now know is, by using standards-based algorithm, you get a benefit. The benefit is many people have tested it, many people have tried to break it, and they were not able to break it. And so the strength of these algorithms is pretty well known. At the same time, the bad guys also know the system.
Right.
They also know how these algorithms work, and they also know how these internet protocols work. And the only thing that they don't know about a specific device is the key.
Right.
So everything has to be still standards driven, but you also need to make sure that the keys that are used to encrypt and authenticate the devices is also equally given due diligence and due importance.
Gotcha. So I mean, that even thinks back to, like, everybody when I went to school had a U-lock, one of those U-locks for their bike. And the reason why everybody had that was not because there wasn't a way to pick the lock, but because everybody knew that that lock was a really hard lock to break. And so, and just quickly for those of us maybe who don't have really any background, what are the common security algorithms, or what are those things that have been well tested?
Sure. I mean, these days, mostly for internet protocols, the key, there are a suite of algorithms that are out there.
Okay.
So I can't really say one or two, but typically the elliptical curve, ECC-based algorithms,
Okay.
Or even RSA. More traditional systems use RSA. More newer systems are using ECC or elliptical curve algorithms
Okay.
for authentication purposes.
Okay.
And for mostly the data transmission and data encryption, it is AES. Again,
Okay.
there are a lot of suite,
A lot of LTLAs.
lot
as
of
my boss
acronyms
says.
out there, but all of that is standards driven. All of these are the TLS or the internet protocols with security.
Okay.
So nothing that is new or unique. It's just that now all of these were being used for your banking systems. If you go onto your laptop and try to connect your any account, there is a specific protocol that is going between your browser and the server. And now you're moving that whole ecosystem into the resource-constrained IoT devices. And the challenge is, how do I bring the same level of strength, the same level of security, but on a much smaller and resource-constrained devices? I think that's where the
Okay.
paradigm shift has to come, and the challenges are probably some of the designers out there are kind of thinking about, how do I shift this and make it more robust and secure?
Sure.
That's what we'll call cipher suites, right?
Yeah.
Cipher suites.
Okay, gotcha. So I used to be able to run this all on my computer and a massive hardware with lots of memory and all this kind of stuff, and I could do whatever I wanted to. Now I have these small things that still need to be as secure as my bank account, but there's a lot less memory and a lot less functionality to work with, basically.
Yes.
So then on the key side, what is the key, or what does that look like?
Yeah, I mean, key really is nothing but a stream of ones and zeros. I mean,
Okay.
at a very low level, but it's 128 bits, 256 bits. whatever it is, it's really based on the type of the algorithm,
Yeah.
the key size changes, but it's nothing but really a stream of binary bits.
Gotcha.
So I think there is a question.
Yeah, I think we got a question in the booth.
So we have a couple similar questions to Tony's, which was, should I be more concerned about physical hacks or remote hacks?
Oh, that's a really good question.
So I would say both are relevant. It really depends on the type of application and the type of benefit that the attacker would gain by hacking the system.
Okay.
Remote hacks definitely have a lot of negative impact. If all these devices, if you have a fleet of products that are all connected to internet, there are search engines that are specifically dedicated to search all the IoT devices, and they can identify that if you search for a specific model of your product, it can pretty much show the entire geographic location and the IP addresses
wow.
of all the devices of that specific model
Okay.
that are connected to internet at any given time.
Yeah.
And if there is a vulnerability out there where one could gain access or exploit the keys of a device remotely, there are significant impacts both from a business perspective, from a brand perspective,
Sure.
because I could do distributed denial of service. I could do, pretty much I could break those devices if I want to remotely from, somewhere out in the world.
Yeah.
So there is significant impact from a revenue standpoint and from a brand perspective point if it's a remote hack. But, physical attacks and the devices that really are getting to a specific device, most of the times what happens is you first get one physical product, you try to check the vulnerability of the product, if there is enough business motivation for that. And after you understand the vulnerability, then you can gain or access more negative impacts as an attacker. So I think both are important, but remote is definitely much more important.
More
Let's
effective.
see, let me give two concrete examples of why you really need to be concerned about both. One of the classic hack we've seen, you buy something connected for the home, right? Well, the problem is that someone who buys it is a black hat, right? A hacker plant a malware and then place the item back on any auction stores or reseller store, right? Now, my wife buys it, it's in my house. I got a problem now. Because what is the malware doing? Who knows, right? Maybe it's a way to turn my connected thing in my house into an access point to a national network. That becomes a problem. Well, you had a physical attack, and now he's ready for a remote attack. Similar case we've seen, it's actually a public case, a security camera get hacked. Well, someone didn't protect the password correctly, right? Well, from that camera that he had physical access to and understood how to get access to the password, it allowed him to actually build a remote attack and launch a DDoS. So that's why you want to worry about both.
Gotcha. So it sounds like you want to be as secure as possible, I think is the short answer to the question.
Yeah, but it's hard because, many times all the designers, they always want their products to be secure. They always
Right.
want everything to be, done properly.
Sure.
But the marketing demands for those organizations sometimes drive them to get the product out quicker, and they're
yeah.
mostly focused on getting the product features out, product capabilities out. How do I compare my product to my competitive product?
Sure.
And security really doesn't touch many of those points
Right.
from a feature perspective. And so unfortunately, it's not the first thing that people think about in the designing process.
Right.
But right after they go to the production side, that's when they think about it.
Sure. Do we have any more questions in the booth?
Actually, yeah. So another question was, how can IoT be used to make our homes more secure?
How can oh, interesting.
That's a massive
Yeah, it's a really good question.
That's a very long question. We'll get through, I think, through the rest of the presentation. We'll try to address your solution. But we started off talking about those confidentiality, integrity, and authenticity concept. I talked about make sure you have a unique, trusted, protected identity that's managed by a cloud backend. Make sure you use secure boot practices, you update your firmware, you use a secure communication, and you manage your user permissions correctly, right? If you have those things, you're in pretty good shape. After that, who knows? Someone is going to find a hole at some point in your system.
Yeah, I think
Security is
it's
not perfect.
It's a very, very good question, but it's not one specific question at one area.
Sure.
IoT is a huge topic, so you need to really look at it from a system level to make sure that everything in the system is, thought through from a security perspective.
Right.
Obviously we are focused on a device level and hardware perspective to make sure that that is, robust and secure. But once the data leaves the device and gets to the cloud, you also need to make sure that the cloud is managed properly and is secured properly, and you don't want to leave vulnerabilities there as well. And we are working with various partners in the cloud side, and we'll talk a little bit about them, where together we are trying to make the whole system secure.
Yeah, and honestly, I think that that's a really good segue into the next thing that we were hoping to talk about today, which is, so I have my data, and really my data, what I'm talking about here, still going back to the security, is I've got my key. My IoT device, my little guy sitting over here, has this key. How does the cloud know to trust that key, and how does even this guy know to trust the cloud with the key? So maybe we can talk about that. I think it's called the concept of trust or something like that, and talk about that next.
Yep. So we talk really about a chain of trust.
Chain of trust.
So what does it entail? Again, what we're talking about here is there's absolutely nothing new. We've been pushing existing practices that the IT industry have been using since the birth of internet. We talk about certificates or public-private key pair, and we'll see how everything works together. For example, when we talk about certificate, you'll hear about X509 certificate and so forth. The whole philosophy is to build a chain of trust between the parties involved into that IoT system. So what do we have? We have a cloud backend, we have an edge node, and we'll have a manufacturing phase at some point, right, to build a product. So if you want to switch to the slide on the laptop here, I'm illustrating those three different layers here. So we have that higher level of authority, which we'll call the ecosystem certificate authority. That is generally held by the product owner, the person who's going to develop the end product. Then in the middle, that product owner is going to contract a manufacturer, right, wherever it is in the world. So now we've got some level of complexity, because as soon as you have a certificate that's involved, you will have a private key that will be in the same environment to sign something. The whole philosophy in security, you sign something with a private key and you verify it with a public key or certificate, right? So where is the private key at the product owner level? We've heard it. It's somewhere. Sometimes it's stored in a USB stick. Good practices would want that to use a hardware secure module of the corporation itself. The middle layer is the manufacturing. So manufacturing contracts are being negotiated all the time, right? So that can happen anywhere in the world at any point of time, and they change for the same product sometimes when contracts are renegotiated. So again, where is the private key associated to that certificate stored, right? There is some vulnerability there. And the third level of certificates is the lowest level. It's the device level certificate, right? What will end up on the embedded device itself? Ask yourself, where is that private key that's so precious? Now, how the three layers trust each other, right? The best analogy I can give, and then I'll go back to the technical facts and practices. If you think about how the US government is being built, you have the federal governments, you have each states, which are reporting to the feds, and then within states, you have cities that are reporting to the states. Within the cities, I'll take the example of my child that was born in a hospital in the local city here. How does she get her identity with regards to the federal government that governs everything? So the federal will call them the root authority, which we call the root certificate here, right? So what happens is, I, as the father, am already recognized by the US government as a citizen of the country. I sign the paper and it's getting stamped by the authority just above me, the city. And that same process of signature and verification happens to the city, to the state, back to the feds. And now we've built a chain of trust between the federal government and my child that was born in the local city here. That's exactly what happens with devices and clouds. You have a root authority that will happen by the end product owner. And the lowest level of participant in the ecosystem, which will be the device, the semiconductor device providers, us, Microchip, right? And we do this signing verification at each layers. And Abhi will go into details on what we do with our factories and our products later on in the thing. And the whole thing that you want to be careful of here is that private key, each of the private key at each layer, you better want to make sure it's extremely well protected and managed and stored correctly.
Awesome. Yeah, that's a really cool analogy. I like that. That makes it pretty simple. One question that I just thought of that kind of pops into my head is, if I am a designer, and I know there's a lot of designers out there, so for the sake of argument, we take a designer at the outmost level. So I'm designing the smart toothbrush or the smart lamp or the smart light or whatever. Which of these layers and certificates do I need to be most concerned with, and what would be my responsibility in this equation, or am I responsible for all of it?
Pretty much.
Okay.
So the higher you go on that particular slide, really the more vulnerable it is if you get any compromise at a certificate authority level, because anything down the chain can all be impacted if from that certificate authority. So the higher you go, the more stronger the storage of that certificate should be. And many times what we see is a lot of our customers and designers, what they go out is they actually work with certificate authority companies. And certificate authority companies will be the ones that hold the root for and on behalf of this customer. And they are specializing in the certificate authority area, where they have lawyers, auditors, they have everything to make sure that the keys are stored properly and are accessed properly. And those are the ones that will be signing our device signers or our intermediate certificate authorities, which are in our factories. And those are the ones which will be provisioning and signing each of the devices.
Gotcha.
And the reason for all of this really is, think of the logistical challenges that many times, customers don't really think in the initial segment when they're developing, some kind of a proof of concept. For the proof of concept topic, it's really, can I get this solution working? Can I just get my message to the internet? Can I see my message at the internet? That's what the focus is all about. When they then switch over to pilot build and really into production segments, that's when it hits. That the scalability challenges. Okay, what should I really worry about in terms of how do I scale it? And at that point, certificate authorities do come into play, because I'll bring an example. I was talking to a thermostat company who were trying to explain this problem, where they were trying to do like 50,000 units per month. They were building 50,000 thermostats per month, and they didn't think about security early on. And the challenge is, every month there are 50,000 new devices that are showing up in the world. And the cloud that is connecting to these devices need to know about these 50,000 new keys that just got out of the factory. And how do you make sure that on an operational point of view, these 50,000 keys are constantly getting loaded into the cloud?
That's a huge problem.
And the certificate authority will get you, from a logistical benefit, because all the 50,000 keys will be signed by a certificate authority. And the cloud, when a new device connects, it presents its new key. Hey, here is my public key. And cloud says, I don't know who you are. Okay, you have your public key. You were born last month. I don't know who you are. And then it says, okay, here's my public key, and here is a certificate. And this certificate is issued by a certificate authority that you trust. And the cloud can then do a cryptographic verification and say, all right, I don't know who you are. I don't know what your key is. But apparently my CA, my certificate authority, trusts you. So with that chain of trust, now I can trust you, and I can add you to my registry. And from next time when you talk to me, now I know who you are. So next time I won't be doing all this heavy lifting, but I can at least have a immediate discussion and say, okay, I can now start communicating with you.
Well, it almost sounds like, taking it back to the government analogy for a second, and correct me if I'm wrong, but it almost sounds like when I'm born, I'm issued a birth certificate and I get a social security number. Eventually I can take that and I can go get a passport. And once I have that passport, it allows me to travel a lot easier, and I don't have to carry my birth certificate and my social security number around with me all the time. But I still have to start with those pieces of information before the US government, or any other government for that matter, trusts me to enter into their country.
Pretty much, and
Okay.
that's the whole point. It's always the first time that's the challenging part,
Right.
because if you kind of relax that challenge of the first time, if anybody can get a passport, everybody will get a passport.
Sure.
So it's the first time that you want to put this rigorous authentication, and once the device can be known and trustable, then from there onwards I can trust it.
Gotcha.
The thing that then comes to play is, how can I make sure that my passport, in your analogy, is stored in a protected way? That
Right.
nobody, because your passport has your photo ID, in a digital number there is no photo ID. So
Right.
if you get a copy of my digital number, you could be me. You could
Right.
kind of show, to the cloud saying that it is me. So
Right.
that's the extra piece where you have to still keep the digital ID pretty secure.
Gotcha.
I think there's a question.
Yep. We have a question in the back?
Yeah, so quite a few people were asking about MQTT and whether or not it was an inherently safe protocol, or how we add security on top of that, and what our recommendations are. Do you guys think you can speak a little bit to that?
Yeah, so it is certainly, so MQTT is at a higher layer. So first of all, you need to have, it's an application level communication protocol, but first you need to have this authentic channel, through the TLS communication, where you verify the device, you authenticate the device. Once you have all of that authentication that is fully done, and communicate the key material, you set up your standard, what's called ECDH or the Diffie-Hellman. Essentially, MQTT doesn't hit the game or of communication until there is significant authentication that happens before.
Okay.
So in other words, really, MQTT is just a vehicle, right, to pass data. But there you go. Now you're already passing data. What Abhi is saying, that needs to happen before you even think about passing data. So you authenticate, you do all that key agreement and authentication process. Then the MQTT is going to start to take in. So it's not really involved with security. It's just a vehicle for the data.
Okay.
Yeah, it's important. It's an application protocol. It kind of communicates between you and me. If I want to send something to you, I can send it over MQTT, but I want to put that into a safe box. I want
Right.
to then send it through some trusted vehicle to send from me to you. Eventually, you still want to get my message, which is that MQTT message, but it is not. It has to be surrounded by the TLS protocols and secure
Right.
authentication scheme.
No, that makes sense. Any other questions in the back?
No, I don't think so. You can keep talking.
Yeah, go ahead.
All right, sounds good. So we've talked about a lot, and I know the first time that I was learning about a lot of this stuff, I had to say it out loud a couple times to get it. So I kind of want to do a quick recap, and then from there we can move into some of the problems, and then we'll finish up kind of talking about how do I practically apply this as a designer. So we started off and we talked about security and the fundamentals of security, which is confidentiality, integrity, and authenticity. And from there we talked about, okay, how do I start applying these things at a conceptual level? And so you have your algorithms and you have your keys. And the key is the unique thing that I, as a private device, have. And with the key, that allows me to enter into kind of what you're talking about with the enter into the communication layers. Once my key has unlocked my algorithm and everybody has decided that they can trust, and that concept of trust has been built, now I can start communicating via MQTT or any number of other communication platforms. But when I try to take that and I try to scale it, and suddenly I'm giving a whole bunch of individual IDs and a whole bunch of keys to a whole bunch of different devices, I need to have a more efficient way to be able to tell whatever they're communicating with that all those devices are trustworthy. And so we have now the idea of a certificate authority, someone who is creating certificates to pass along with each of these keys to say, not only is this key the correct key to this device, but it is a trustable key because the certificate authority has put its seal of approval essentially on it. And so when you're passing this binary key, you're also passing it along with this certificate as well.
Yes.
Okay, great. So what then are, outside of just the inherent complexity of what's going on, what are some problems that people can tend to come with, or like where are the highest challenges for people getting started with this, or even more advanced stages?
Yeah, so there are a lot of challenges that people. So first of all, it's the awareness. Awareness is a challenge. A lot of times designers don't have a lot of awareness on the importance of key storage. They do give importance to the algorithms because the standard protocols, the standard TCP/IP networking protocols, they kind of inherently require some strong algorithms to be communicating between the cloud service platforms. So algorithms, because of the requirement from a TCP and the TLS protocols, is already there. A lot of times awareness of the key storage is not given due importance. I can say that's definitely one of the key challenges. The second thing is a lot of times designers pick the microcontroller based on probably I would say 3 key categories. Performance.
Sure.
Does that micro meet the performance I need?
Right.
The second thing I would say is power. Does that micro fit the power budget that I have? Right? That's the important piece. The third one is, does it have right memory that I need? Does it have more memory, less memory? Less memory is better cost, and those are the 3 that people are trying to look for when they get a purchasing decision to get a part. And more often than not, most of the microcontroller teams or most of the other silicon developers, when they're designing a microcontroller, those are typically the top 3 priorities for them as well. They are focusing on those 3 categories. Security is probably kind of competing with all 3. Sometimes to make it secure, your performance may get impacted. To make it secure, sometimes you need to be looking at the power, because there are some attack vectors that could be impacted by your power profiles. So you need to kind of play games on how you show your power consumption, even though when you're doing some calculations, and also memory. So the challenge here again is the designers are picking these microcontrollers for other reasons, and how do you make that system still secure while still getting all of your requirements from a micro perspective?
Right. Okay. That makes sense.
That's one. The third one I would say is logistic challenge. How do I ensure that the 50,000 example that I talked about earlier, that every month if I'm building 50,000 boards, somewhere in contract manufacture in some part of the world, how do I make sure that all those 50,000 every month are getting unique keys per device that are not vulnerable? Because now if the contract manufacturer has knowledge of these keys, the vulnerability is at the CM, the contract manufacturer, because they are the ones who are injecting these keys on every device.
Right.
They have to maintain that key material in a secure way. So the vulnerability as it gets through the provisioning process is important. The storage of the key on the microcontroller has to be important. The usage of the key from the software perspective has to be important. If I'm writing my example, or my application for thermostat or the lock. I'm doing my lock example or application code that has to touch these keys. How do I make sure that that software is not vulnerable or has any, deficiency in any kind of code that can potentially exploit the exposing of these keys? So that's more of the usage of the keys that need to be also thought through. So quite a few challenges, really.
That's what it sounds like. Well, then, I guess, how do you, if I was to boil this down to a few key points about keys, it sounds like it's how do I generate the key, how do I use the key, where do I store the key, or how do I embed the key, and I guess those are the last 2. How do I embed the key, and how do I store the key? And so, kind of jumping off of those 4 questions, Microchip, obviously we work for Microchip, and I know that we have done some things to kind of try to take this really complex process of security and move it into, because like you said, if I'm a designer, usually I'm going to be really good at something. And if I am a product designer, I'm really good at designing the product, but I may not have a lot of experience with security. So what have we done, or how do I get started to the practical embedded level of moving forward with security?
I don't know.
Xavier?
Okay. So I mean, what we have is, if you want to switch to the slide here, can we switch to the slide on the laptop?
He's
There.
Wayne.
the laptop. There you go. So what we have really to address a lot of the, you've seen all across this discussion, we talked about protecting the keys. Okay, that's fine. Let's talk about a single product that I have in my house. So we have this thing called secure element. We have a whole portfolio about it, and we'll give an example of what we are offering with it. What this thing is, it's a secure boundary that has the crypto algorithm that will basically deal with the keys. The keys will be solicited by. So now, the important thing is to really have this key with the crypto algorithm into that same boundary. If they are starting to be separated, you're going to create some type of backdoor. So that secure boundary, where the keys and the algorithm is, again, it's very important. You want to make that flexible as much as you can. So now imagine I have that one connected thing in my home, and I want to have, I'm a product owner, and obviously I want to send millions of them. Well, how do I deploy that secure boundary across millions of devices? Well, that's where the secure element comes in. It's a companion device to any type of controller, whether it's 8-bit, 16-bit, 32-bit, or even Linux microprocessors. You snap that secure boundary next to it, and you have that. What we've done with this type of secure element, we submit it to third-party labs to validate our statements. And those third-party labs have basically about 30 days to access the keys. So we give them loaded with keys. And after 30 days, you're getting graded. It goes from 1 to 31, or you have a high level. The 1 to 31 means the keys have been accessed to with more or less difficulty. The high level grade means the keys have not been extracted in that period of time. Well, lucky us, our latest secure element has been graded GIL high. The GIL high is part of the common criteria specification, which is the body that also tests for smart card, SIM card, payment application, and so forth. So it gives us a very high level of confidence that secure boundary is actually pretty robust. Here we have a question.
Yeah, I think we got a question in the back.
So we have a question about Jared is wondering, we have been focusing a lot on the ATECC 608A and the ATECC 508A, but can we give like a brief high-level overview of the differences between the 608A and the ATSHAA 204A?
Yeah, we're
just our other secure
we're
elements.
reading the comment as we go, which is why we're not on camera, because you know, we have a lot of papers here.
Let's see if I remember everything, jump in time. So the big differences are, so the 508 was released about 7 years ago. Well, what happens is, again, I talked about certification, right? So we look at the NIST specification, and they evolve across time. So across the 7 years, you can imagine the specification has evolved. There is something very important that I was showing the slide. There is the random number generator. It's probably the most important piece of security as a whole, right? That randomness is what will build those unique identity, the keys. Well, NIST specify the noise source level to a certain level, and that level has changed between 7 years ago and today. The 608 matches that new level of noise source. That's probably the most important one. The second one, we added an AES accelerators. We added ECDSA verify function that allows you to do secure boot and over-the-air update, for example. What else am I missing?
Yeah, those are the key. But I think the question was related to the SHA-204 or SHA-204. And I think, so today's session is all about IoT, and AT SHA-204 is still a very relevant product that is still for authentication purposes. But majority of our customers really use the SHA-204 secure element for authenticating disposables or accessory products. Like if I'm connecting a battery to my product, I want to make sure that the battery is from me and not from counterfeit company.
Okay.
So connecting something that's more local, we have huge applications in the SHA-204 segment, which are in the disposable area, or when I say disposable, like a medical product that I just plugged in, I want to know that it is not a counterfeit product.
Yeah.
In the e-cigarette market and the cosmetic market, I'm trying to connect my cosmetic entity to my unit, and I want to make sure that it is not a counterfeit device, or to eliminate the counterfeit market and to protect my revenue as an organization. Those are the segments where I would say SHA-204 would be more applicable. For
Okay.
the IoT segment, which requires the level of elliptical curve-based authentication schemes, which majority of the TCP/IP protocols typically require, or the TLS protocols require. That's where we are focusing more on the ECC product line for
Okay.
today's segment.
And Abhi, the other part mentioned by Jared was the ATAES 132A, so I'm going to assume that the comment that you made is pretty similar.
Yes.
Just different market segments.
Exactly.
So we talk about symmetric and asymmetric authentication. So ECC asymmetric, the ECC family actually integrates SHA algorithm too. The SHA is specifically for symmetric authentication.
Yeah, the ECC family is, you can think of it as a superset of SHA.
Okay.
So ECC has everything that the SHA-204 has and more, and that's primarily because it supports all of the TLS communication
Right.
standards, which SHA-204 doesn't really bring, but is still very much applicable for the segment of market, which is disposable and accessories.
Okay, cool. Any other questions?
Not right now.
Sounds
We have a lot of questions.
Yeah, sorry, we've had a lot of questions, and we're really sorry if we're not able to get to your questions, so please send us an email so that we can put you in contact with the right people. But for the sake of time, I think...
Yeah, I think at this point we'll just kind of move you along, and we'll try and get to the questions, the relevant ones, and the ones that are kind of pinging us by having you email us at livestream@microchip.com, because we have a ton. Just want to make sure they're germane to the material, and I don't want to throw you guys off course either.
We really want to answer your questions.
Totally.
And we want somebody knowledgeable to answer your questions, and unfortunately, I don't know everything.
So where I was on the
Secure element.
The secure element, and the fact that we go through certification brings us a high level of robustness. And what that secure element really is, Abhi mentioned the logistical challenge. Now here you go, I've got millions of devices that have to have that private key handled correctly. Well, you can see that secure element as an envelope, a secure envelope, where the private key is going to be shipped into. Because right now, we're presenting at the Things Network conference. So for LoRa technology, those keys are literally shipped in a piece of paper, printed on the paper or an Excel spreadsheet, and that's what you get. So if I get that, I get access to the network. That's what that is. So now that secure element, look at it again as an envelope, a secure envelope to ship the private key all over the world.
Okay.
And that's what Abhi's team has been doing. And for that, we talk also about provisioning service. I don't know if you want to throw a few words about it.
Yeah, I mean, what we really bring and what we are trying to work on is there are different aspects or different problems that we talked about so far in the first section, which
Right.
probably is intimidating and a bit concerning to say, okay, this is too hard.
Right.
But really our job is to make it easy. And how do we do it is the secure element, first of all, is designed to only one purpose. The three things I talked about earlier, the performance, the low power, for us, that's not the priority. Performance is not the priority, low power is not the priority, memory is not the priority. Priority is how do we make the keys secure
Right.
and protected against well-known attack vectors out there in the market, and how do we ensure that that particular key and the primitives, the crypto primitives go along into the customer's applications without them getting exposed to any kind of vulnerabilities. That is our job, that is what we are doing. So most of the challenges that I've been talking about earlier is really what we keep looking at every day and trying to figure out how do we make those challenges removed from customers' table and say how can we help them get their products quicker to the market, still
Right.
secure in the market. So the secure element that we were talking about earlier, that solves probably 2 or 3 of the challenges in the challenges I talked about, which is how do I store the key? How do I use the key? So secure element stores the key, so you don't have to worry about it. You don't have to know how to get the key, because first of all, the device will not give you the key even if you ask for it. But then we also have protocols on how to use the key without retrieving the key. So
Okay.
there are mechanisms for you to talk to the device to send a challenge and get a response without ever getting the key out of the device.
Okay.
So that solves 2 problems, which is how do you store and how do you use.
Okay.
The next big challenge is how do you put the key into the device.
Right.
That's a big challenge because, as he pointed out, a lot of times we talk to customers who literally send them batches of these files with keys, and customers, as they are building different boards, they take one key, put it into one board, second key, put it into second board. That's the way it's done today. That is a huge vulnerability because that file has all of your key material.
Right.
So in our device, really what the device does is it can generate the key without ever revealing the key.
Oh,
so
cool.
the way that it does is the device will internally, using the random number generator that Xavier mentioned, will generate the key so that nobody except the key has knowledge of the key.
Oh, wow. Okay.
So that solves the provisioning of the key or the key generation of that. Now the fourth problem is certificate injection. So how do I ensure that
Right.
now I can trust that key? So the device will only give out the public key. It will store the private key. We didn't go really into the details of the technology here, but private public keys are kind of, they go together. And
Yeah.
the private is what you store, public is what you give.
Gotcha.
So the public key is what the device gives out, and the certificate authority can sign it, and you provide the certificate back into the device. And we do all of that for many of our customers. So literally from a customer's perspective, what they do is just buy, or get the ECC 608 from us that is pre-provisioned, and it's ready for their application. And all they have to do is they give that part number to their contract manufacturer. Contract manufacturer just gets that part along with many other parts that they have to use for building their product. And that's the way the CM never has knowledge of the key material.
Oh, great.
Microchip has never the knowledge of key material because the device is generating the key itself.
Randomly,
And
yeah.
really the whole system from the time the part has been generated to the time that the part has been at the end customer's location, the supply chain logistics has been taken care of.
Great. That's awesome. So then maybe just to close the conversation, if I am just getting started IoT, I know at least a portion of our population has just gotten started with IoT, and I'm like, I don't want to make the mistake of not implementing security before I'm creating 50,000 units. What's a good way to bring in security without necessarily knowing security perfectly from the beginning? Or how would I get started
Yeah,
with that?
so there are two aspects to it. Maybe I'll talk about the software and then he can take on the hardware side. So from a software perspective, one of the key things that customers or designers would be thinking about or contemplating is, all right, I really see the value and I see it, I like it. Where do I get started, as you pointed out?
Right.
So we have a library that we provide on GitHub, CryptoAuth library. So if you can maybe move it to the screen. So that's on GitHub. It's posted and that library can support pretty much all of our secure elements. And this is portable across multiple microcontroller platforms. We have it running on our 8-bit, 16, 32-bit Linux platforms, even outside, many other platforms outside of Microchip as well. So any product, any customer who is looking to add security, they can just take this library, port it onto their microcontroller platform of their choice, and that way they can make their system secure.
Oh, awesome.
From a software perspective.
Okay.
And also we are working on various hardware tools, and maybe do you want to talk a little bit about that?
Yeah, I'm going to try to pull the slide here that we wanted to show. Yep. There you go. Yeah,
It's loaded.
there you go. Hopla, wrong one. So we, with all the business unit at Microchip, we put quite a lot of effort in development kits to get you guys started. So we did a lot of work with Google, Amazon, and a bunch of other partners. Here you're looking at the offering we have across the company to connect your hardware to Google IoT Core. So if I go from left to right, you get the most demanding implementation will be on the Linux, you'll be using Linux platform. To get a cool example here, so if you go to microchip.com/GCP, you'll find all those solutions. So you'll arrive in the landing page with the hardware, and generally all the code is hosted on GitHub to set up the hardware. So Linux on the left side, then you go down to the smallest controllers towards the right. We've got a SAMI54 that was announced, I think, 2 weeks ago at Embedded World, where we were demonstrating the new Google CSDK on the SAMI54, it's Cortex M4. The two boards in the middle, that's SAMG55, SAMD21, those are an M4 and M0 concept. Those are the first concepts examples, I should say, we released about almost 2 years ago now. And then on the right side, you had an example for a PIC24, 16-bit microcontroller. And on the very right side, you have the Atmega 4809 that it's basically an AVR microcontroller still using, most of them are using or Wing 1500 or 1510. On the 1510, the cool thing is you could use the memory of the Wing 1510 Wi-Fi to do an OTA. The wireless team has been providing a firmware that gives you access to that piece of memory to do an OTA on small microcontrollers.
And what's an OTA, just for those?
OTA, yeah, over-the-air updates.
Okay, okay, cool.
Yeah. So if we go to back to the screen here, we're showing here a bunch of solutions for AWS IoT Core. Same thing on the left side, you're going to find the Linux environment. So we've been approved by AWS as to be part of their device qualification program with the ATC608 because we integrated that solution within their hardware. Forgot the S. Hardware Secure Integration, I think. That's what HSI is what it stands for. And then in the middle you have the SAM G55, also the M4. You had a SAM G55 with embed TLS. And then on the right side you have a PIC 32 MZ that is also part of the device qualification program. That's actually not SAM G55, it should be a SAM E70, not G55 on the third board. And the last one I'll show you is actually, we launched that on the 31st of January. That is the next level of simplicity we're bringing to the market. So if you think about what Abby was mentioning about the provisioning service, what I talked about building a chain of trust here, this is what we've worked on with TTI, the things industry for the LoRa market. Here we use the SAM R34, which is a combo integrating an M0 and a LoRa radio. Or we also have a SAM L21 concept with a Semtech discrete radio, all using the 608 that's pre-provisioned, pre-configured, and pre-provisioned with the necessary key to connect to a TTI network. So what happens is you buy this device, you get a manifest file from the Microchip store when you buy the device. You download it, you upload it to the TTI interface, and you claim the device automatically to your accounts. And now you claim that batch of 608 that you've purchased through. And everything we talked about for the past hour, we completely eliminated it. What it allows you to do is to concentrate on developing your application and not worry about secure authentication. And I think that's it.
Great. Thanks, Xavier. So we'll give you all this great information, and then if you want to just completely ignore everything we just said, you can do that last option as well. So it's great. We try to make it as easy as possible. And on that note, do we have a couple last finish-up questions?
Yeah, actually, we do have a couple of questions. So Rachel has one, and I have one. You want to go first, Rachel?
Sure. So Bello asks, if I want to secure my IoT projects, but I lack network security knowledge, what do I do in order to secure the projects easily without having to pause and learn the security skills?
Yeah, that's a good question. I think many of our customers really fall into that category, and that's why the tools that we just talked about really are the getting started, because the Wi-Fi modules that we have, those take care of the networking protocols. So the whole TCP/IP networking, the TLS protocols, everything is taken care of by getting the Wi-Fi module, the Wing 1500 module. And the secure element takes care of the key storage and how do you use the keys and how do you provision the keys. So if you look at the AVR IoT board, for example, the AVR application that's running on the AVR chip or 80 mega chip really is not putting a lot of effort, or a designer would not have a lot of knowledge, or even the chip doesn't even have the networking protocols in it. It's talking on UART or SPI actually to the Wi-Fi module. It just sends the packet of data. Hey,
Right.
here is my 23 degrees centigrade. Or here is my unlock command.
Right.
I send it to the Wi-Fi module. Wi-Fi module does the whole networking aspect of it, sends it over to the cloud. Anytime when there is a security requirement like the authentication piece, AVR just communicates as a pass-through between the Wi-Fi module and the secure element.
Right.
And the secure element sends the information, get a challenge, sign it, send a response back. AVR is not doing a whole lot of, heavy lifting.
Right.
And the designers really do not have to have a lot of knowledge on networking or security.
There you go.
And that's the whole point. And the new board that we are talking about, the PIC24 or the PIC IoT board, same concept. The microcontroller and the firmware that you'll be developing is focused on your application, what you are trying to do for your application. The whole networking will be taken care of by the network controllers, and all security is taken care of by the secure element, and you don't have to worry about it.
It's still a good skill to acquire. There are some basics, and I actually propose a series of tutorials, basic tutorials, which we call cryptography primer. So if you Google Microchip cryptography primer, you'll see a link to the list of video we're proposing. We talk about hashing, symmetric authentication, asymmetric authentication, the concept of trust, and we show you how keys are or should be and how they are being used and whatnot. It takes about an hour and a half to go through that content. I do encourage you to go through that. It's basic and powerful, I think.
Very
Yeah,
cool.
and we can link to that in the description as well after this video gets done to make sure that it's as easy as possible to find that playlist.
Yep.
Cool. So we've got one last question we can ask, and it's been amazing in the comment section. We certainly appreciate all of the people who have spent their time asking questions. We've dropped our email address, livestream@microchip.com, in the comments. So if we don't get to your question, you really need it answered, send that over to us. Send the question over to us. We'll get it to Abi and Xavier. I'm going to ask one last question, mostly because I'm curious about it as well. Radish asked a question about basically an AVR IoT board. So if he purchased an AVR IoT board, can he re-provision the ECC 608A chip that's on it for, I guess, another network or another system?
Yes. The quick answer is yes. There are some ways to do it. The way that you implement it is very important, but absolutely the answer is yes.
Cool. Very cool. Okay. Matthew, do you have anything else?
I mean, I think that covers it for us. We do have some giveaways, I believe. So the PIC IoT board that Abhi was just talking about, I think we're going to give a couple of those away this time. And so if we want to take it back to the booth, y'all can let us know who the winners are.
Absolutely. So we're gonna drop it on the screen here, and everyone can see.
So the winners are, and I'll announce your YouTube handle, Student Companion, Nuno Felicio, and Juan. I'm not sure how to pronounce your last name,
Go for
but
it.
send us an email. So just send
I
us
don't
an
think that's
email
how you
at
pronounce it.
livestream@microchip.com.
I thought you were gonna go for it.
Kongawala?
Hey, that's pretty good.
There you go.
Actually, I can't be the judge of that.
Yeah,
but
I
it
think
sounds
only
pretty good to me.
Juan can judge. But if you guys could just send us an email and we'll get it all set up to send you your prize, a PIC IoT brand new board. Should be really exciting. And also keep in mind that this is just Wednesday of IoT Design Week. So tomorrow,
Heck yeah.
Wow, just Wednesday.
we will. I know it feels like a lot. Longest week of my life. No. So Thursday, tomorrow, we will have DigiKey in town.